area and the perimeter of a rectangle. So I want you all to read yesterday's I can statement with me on 2. 1, 2.
I can find the area and perimeter of a rectangle.
All right. Raise your hand if you can remember the song that we've been singing. Good. I want to hear you all sing it to me nice and loud without shouting.
How did you do that? Find a shape perimeter, perimeter, perimeter. To find a shape perimeter, just add all the sides. The rectangle area, yes, rectangle area is one side times the other, and area you'll find.
Very good. All right. So let's do a little bit more review. If you have a rectangle that is 10 centimeters by 6 centimeters, how are we going to find the area? Someone raise their hand and help me out. Jaden. 6 times 10. So I'm going to do 6 centimeters times 10 centimeters. Tell your person sitting on your, tell a neighbor what is 6 times 10. Alright, so I'm hearing all around that 6 times 10 is 60. Thumbs up if you agree. Good. Good. I'm so glad that you all remembered that. Alright, somebody raise their hand. How am I going to find the perimeter of this rectangle? Espen.
Add all the sides.
Add all the sides. So I'm going to do 10 plus 6.
No, you have to add all the sides.
Right?
You have to do 2 more, 1 more 6 and 1 more 10.
Right. So this is an issue that I saw on a couple of people's paper yesterday is when I only give you 2 sides of a rectangle, you all forget about the other 2 sides. If this is a rectangle, do I know what this side is?
Yes.
What is it?
10 centimeters.
And if this is a rectangle, do I know what this side is?
Yes.
What is it?
What?
So I need to add those in there also. I want you to tell your neighbor what is 10 plus 6 plus 10 plus 6. No, I'm just all right, somebody raise their hand and tell me what your side of the room came up with. Zach? 36. I'm going to check that. So I know that 10 plus 6 is 16. And 10 plus 6 is 16. And I know that 6 plus 6 is 2. And I have to, it's 12, sorry. I have to carry my 10, so now I have 1 plus 1 plus 1.
32.
I knew it! I knew you all need to be careful. You guys have to be careful, Abby. Do 2 at a time. Don't try to do all 4 at once. You're going to get yourself lost. Break it down to make it easier so that you make sure that you get the right answer. Do I need to square this?
No.
Why not? Kayla?
Because that's adding.
Because I'm adding. Why did I need to square area? Sabrina?
Because it is times.
Because I am multiplying. If I multiply a unit times a unit, I get a
Unit square.
square unit.
Let's not to say unit.
them is I can decompose an irregular figure into non-overlapping rectangles. I want you to go ahead and write that down in your notebook on your next clean page. And I want you to have the date on there also. When you have that done, I want you to put your head on your paper.
So do you put the roll?
No. All right. Raise your hand if when I read that your mind went, what? That statement is really thick. There's a lot of weight to it. So let's break it down just a little bit. So the statement was, I can decompose an irregular figure into non-overlapping rectangles. Who can remember what decompose is? It's one of the vocabulary words that we worked on Monday. Decompose. Michael?
To break apart.
To break apart. And you all do not have to write this, I just want you to see it. So we are going to break apart an irregular figure into non-overlapping rectangles. What is an irregular figure? I want you to think about what a regular figure is first. And then what is an irregular figure? Aaliyah? You're right, it is a figure that's not like the regular figure. Let's see. Talk to your neighbor and see if you can figure out what is an irregular figure. Start with what is a regular figure.
I know a regular figure is something that has like a square or a rectangle. But what is a regular figure? Size is something that has like
What did you come up with for a regular figure? Emma?
Something that has equal size.
Something has equal sides and equal
Angles.
angles. Equal sides, equal angles is a regular figure. So what would an irregular figure be? Kayla?
Probably.
Mm-mm. Sabrina?
No equal parts.
It doesn't have equal sides or equal parts. So remember, when we do a square, all of the sides are equal and all of those angles are equal. But if we do, are all of those sides and angles equal?
No.
No, this side is shorter than this side, which is shorter than this side. So an irregular figure does not have all equal parts. What is non-overlapping? Non-overlapping. Michael?
It doesn't overlap.
It doesn't overlap. Show me with your hands overlapping. Justin's got it. If you put one hand on top of the other, they're overlapping. Do that. Trisha. So my hands are overlapping. Are they overlapping now?
No.
No. So now they are non-overlapping. Show me overlapping. Show me non-overlapping. So you can break down a figure that has not equal parts into non-overlapping rectangles. So they would be two separate rectangles. So now that we know what that really means, I want you to read that with me on 2. 1, 2. I can decompose an irregular figure into non-overlapping rectangles. Good. Oh, oops. Sorry. Oh, wow. Alright, so for example, if I have this shape and I want to have them in non-overlapping rectangles, then I'm just going to cut it somewhere so that I have two separate rectangles. Does that make sense?
Yes.
I wouldn't want to do this because I have a rectangle and then it looks like I could have another rectangle and then it looks like I could have another rectangle. No. I also wouldn't want to do this because is that a rectangle?
No.
Is there another way that I could have done this one?
Yeah.
Michael, come show me.
Like, instead of drawing on that, you could have just drawn that side up here and it would have done that.
Now, why do you say that?
Because you don't really have to cut anything right there, so you could just pick that.
Now, did you just decompose that shape? Did you break it apart? No, what did you do? Yeah, so we don't want to add to it. Can somebody else come show me? Zach? There we go. So if I go, now I have a really skinny one and a square. Are those two rectangles?
No. Yes.
Yes.
No rectangle. Oh my God.
You don't see that rectangle.
Both have true rectangles.
Thumbs up if you say a square is a rectangle. Thumbs down if you do not. I see hands up. I don't see very many thumbs. Okay, thumbs up. A square is a rectangle. Remember, we talked about the only thing that's a square can be a rectangle, but a rectangle can't be a square. Wait, I said that backwards. Yeah, a square can be a rectangle, but a rectangle isn't always a square.
It looks like a rectangle.
I want everybody to look at these really quick. So your eyes should be on the board. Quickly at the sinks. Eyes at the board. I want you in your mind to cut those. I want you to decompose those into two rectangles. One of them, or two of them, you might actually have more than just two rectangles. When you think you can do one, raise your hand. Rashana, I don't see you looking. All right, let's see. Daniel, come decompose one of those. Raise your right hand if you agree. Raise your left hand if you do not. Good. Your right hand should be up. That is correct. Espen, can you come do another one?
I don't like when you do those.
All right. I'm going to call 3 more names and you guys come up quickly. Sabrina, come do one. James. And Landon, can you do one? What Jojo said. Quickly, guys. Put your feet still. Thumbs up if you agree with Sabrina. Good. Next. To your left. To your left. There you go. A little bit more down. Thumbs up if you agree with James. Are those 3 different rectangles? Yes, they are. Good. And Landon, can you do another one? So you have this one left or that one?
I think that
Alright, Landon's going to pick somebody to help him out. Alright, Zach. Are you 3 listening? It doesn't look like it because your eyes aren't on there. Alright, I want you all to look at that. I want you to look, Landon. Does he have 4 rectangles? Does he have any irregular shapes inside of that? No, he doesn't. He has 1 rectangle, there's another rectangle, there's another one, and there's another one. Good job. And then the last one, you could go like this.
Yeah.
Or I could go like that. Or you could even do both.
That one more. Wow, there's still 3 rectangles.
Alright, so I think you guys have that. Our second I can statement, I told you we had 2. is I can find the area of an irregular figure. I want you to write that down underneath your last one.
When I was doing my homework, my dad, he told me like decompose in when we were finding the area of the wheels in the L shape.
Mm-hmm.
Told me I didn't do it.
Do what?
He told me that he does. Like he separated the two shapes.
Mm-hmm. So you did it like that on your homework? Good. All right, thumbs up if you are done writing. Great. I want you all to look at that shape. So if I'm standing beside it, I should be able to see everybody's eyes. I got a couple of girls not looking. Here we go.
What is that, Dad?
If I asked you to find that area of that shape, would you look like that? That's what I'm thinking. So I'm going to break it down for you step by step. First one is you have to decompose it. What am I going to decompose it into? Keith? How many? Do I want 4?
No.
How many do you think I could make out of here? Let's just do 2. Let's make it easy. And I'm going to do it this way. Okay, so the first thing you got to do is decompose. You girls with me? How about the girls sitting behind you? Step 2, Abby, you are going to find the area of one of those rectangles. I'm going to go with the small one just because it's a little bit easier. So I want to find the area of this one. I'm going to take my length times my width. So I have 4 centimeters times 2 centimeters. What is 4 times 2, everybody?
8.
Good.
8 centimeters square.
Good. 8 centimeters squared. Then I'm going to find the area of my second rectangle. So now I have this really big one. Should I do 6 times 12?
No.
Thumbs up if you say yes, thumbs down if you say no. Should I do 6 times 12?
Nope.
Good, it looks like most of you are saying no. 12 is this whole long part, but I've already cut that off, so it's not 12. So I'm going to go with 8. So I'm going to do 6 times 8. Tell your neighbor what 6 times 8 is.
No, it's not.
Raise your hand when you think you have it. Jade? 6 times 8? I don't think it quite got big enough. Zach? 48. 48. You guys gotta practice those. Just don't do that. Alright. Hands and eyes. Hands and eyes. Hands and eyes. Thank you. So now I have the area of my small rectangle. the area of my large rectangle. I'm just going to add those two together. So I'm going to do 8 plus 48. What's 8 plus 8?
48.
16. Got to carry my 10. What's 1 plus 4?
centimeters square.
So now the whole area of this shape right here at the front of the room is 56 centimeters squared. Thumbs up if that sounds reasonable. Okay. Sabrina?
Why does the area that is times in the perimeter gets to a plus? I don't know.
I want you to think of it. Let me see this. No. If I were to find the area of this rectangle, so I want to know how big is this rubber band. When you think of perimeter, what you want to think of, if I were to take this rubber band off and cut it.
Oh, don't cut it. No.
And then I have it out, and it would work better if this was a string and not a stretchy rubber band. And then I measure this with a ruler. That's the perimeter. So that's why I would add one side, plus the other side, plus the other side, plus the other side, because it's all one big long string. Right, Trayshawn? But if I want the area, then I want to know what's inside of that rubber band. What can fit in there? I want to know how many. So this is a 1, 2 by 1, 2, 3 rectangle. I want to know what 2 by 3 is, which is 2 times 3. 2, 3 times. You could do 2 plus 2 plus 2 3 times if you wanted to add. But when you get those really big ones, it's just easier if you multiply this side times this side. Like when we did the arrays for multiplication. I'll talk with your group, okay? Distracted. There we go. Alright. I want you all to keep one, pass the rest. It might just be like your homework. Pass those back. Keep one, pass the rest. Alright, everybody should have a paper in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Good.
No fair.
Everybody did it. Alright, your number 1 should look like this. If you look down at the bottom and look at page 3, make sure there's a 3 at the bottom. Your number 1 should look just like this, right? Nod your head if you agree. Good. We're going to do this one together. Now I want you to look at that irregular figure. And I want you to put your pencil beside your paper. And I want you to look at that figure. And I want you to imagine that figure into 2 rectangles. Raise your hand if you imagine the rectangles like this. Like this. Good. This would be the easiest way to do this. You see this chunk coming out, this chunk coming out. We could have done it that way, but we don't know what that length is. Would it be easy to find that area?
No.
No. We could have done it this way too, and when we would have had 1, 2, 3, but do we know all of that yet?
No.
Not really. So the easiest way to do it, I want you all to start thinking about what is the easiest way to do it. Not just any way. Make it your life simpler. Okay? So we want to find the area of one of these rectangles. Which one should we start with, Emma?
I think you should start with the smaller one.
Okay, which one's the smaller one? Give me the dimensions. 2 by 4. And if you look at the directions at the top of your paper, it says that you are using millimeters. So I have 2 millimeters, and I want you to copy this on your page, times 4 millimeters. And I'm doing this one first. Copy this on your page, right here. Copy that on your page.
Like this?
Yes, sir. Make sure you get that line where you decomposed it.
There, I'm done.
All right, what is 2 times 4, everyone?
8 millimeters. What? I said 7 at first.
Not millimeters, 2 millimeters.
Where?
All right, now I want to find, I hear lots of chairs coming from over there. Can you all please hold still? It's distracting
That's why.
because I keep wanting to look at you all instead of paying attention to what I'm doing. The next one is 2 millimeters times what? 6 millimeters. We're still finding area.
We're on the next one.
No, we're still on number 1. We did this rectangle, now we're doing this rectangle.
Are we still doing this? Sorry.
Yes, we did this rectangle, now we're doing this rectangle. All still on number 1. Good? What is 6 times 2?
12. After we put that in our little box.
Now what?
That on
Rena?
size.
12 times 8 millimeters? I don't think we want to multiply anymore. Brianna? 12 plus 8. I want you to look at the colors that I use. So everybody put your hands on your shoulders and face me. Everybody put your hands on your shoulders and face me. I'm still waiting. I'm still waiting. Oh. Look at these rectangles. I did blue and I did blue. I did red and I did red. I did 2 separate rectangles. This is one rectangle, this is another rectangle. I want to put them together now. So when you put things together, what are you doing?
The same thing.
When you put things together, what do? You're adding them together. You're putting something together. If I put Keith together with Zach, I'm adding them together. When I put Keith's desk up to Daniel, I added Keith's desk to this row. I have this rectangle, and I have this rectangle, and I put them together. if I want to find the area of this rectangle and the area of this rectangle, then I'm going to move it. I'm going to find this one, and I'm going to find this one, and then I'm going to add them together to find the whole thing. So we are going to do 8 millimeters plus 8 square millimeters plus 12 square millimeters. What is 8 plus 12?
20! Then you got that right.
Good. All right. Now I want you all to think about this. Do you think you're good to go?
Yeah.
Do you think that you can, listen, do you think that you can finish this whole page without any more help? I want you to think. If you think that you need more help, I want you to put a star at the top of your page.
Can we probably use
If you think that you're good, I want you to draw a heart at the top of your page. And I want you to really and truly think about that. Do you need more help? Don't just say, I don't need help because you don't want me to talk anymore. Think about that. I'm going to take this paper and it's going to be a grade. Do you want a great grade? Or do you want a not so great grade?
Yeah.
Okay. Alright, so I've changed our group so nobody move. When I tell you where your group's going, I want you to freeze until I tell you to move. Group 1's going to go to reflex first. Group 2, you're going to come to the carpet with your paper. You may grab a clipboard or a folder so that you can write. And group 3, you need to think about this. Do you need more help? If so, come to the carpet. If not, stay at your seat. Finish that paper. Group 1, listen. I shouldn't see anybody out of their seats yet. I haven't told anybody to go anywhere. Group 1 is going to be Justin, Daniel, Sabrina, Terry, Keith, Landon, Alex. Okay, you all go ahead and move to reflex. Go ahead and pull that out, it'll work. Alright, group 2. Jade, Espen, James, Michael, Zach, Kayla, Brianna, Abby, Jaden, Trayshawn. Come on to the carpet. With your paper, grab the clipboard if you want. Quickly. Alex, you may come grab this iPad. No. Alright, group 3, raise your hand. I haven't called your name yet, you're group 3. If you need more help, come to the carpet. If you do not, you may finish. Abby, I believe that you were part of group 2, so you should be over here by now. You are. Come on. What did you know that? Come on, she grabbed the folder. No.
Do your best.
Alright, if you're on the carpet, clap your hands once, twice, 3 times. Alright, I want you all in rows of 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, move. Espen, I would love it if you'd stay right up here. Thank you, sir. Trayshawn, I would love it if you came sat right here. We're going to do rows of 4 instead. Michael, you're good right where you are.
I can't be
You're right. So how about yeah, you just move back. Good idea. Alright, I want you all to look at number 2. Circle 2 on your paper. Circle 2 on your paper. Yes. Brianna, you're going to be our calculator person for the carpet. This doesn't look like a very good row. It looks like a U. Can you all fix that for me? That means you're going to move over. Move, move. Move, move, move. Perfect.
Really?
Much better.
You ripped it.
You should have circled number 2. Thumbs up if you did that. Alright, I want you to look at that irregular figure. Say irregular figure.
Irregular figure.
Decompose that irregular figure really quick. You should decompose it into 2 different rectangles.
No copy. Yeah, no copy. No copy.
So I have some people, look up here. Look. Look. Jaden. I had a couple of you do this.
That's not it.
Is that the easiest way to do that?
No.
Why not?
Because there's only a
Hey, Sean, why wouldn't we want to do it that way? Because why? What's not equal? Well, we don't necessarily need equal rectangles. Espen?
that one's that and that one's good.
Well, again, they don't necessarily need to be the same size. Zach?
Because there's not a number with the 3.
Right. How long is this side?
1 inch.
We don't know. We could make an inference, but we don't know. How long is this side?
We don't know.
We still don't know. We know it's less than 4, but there's no way for us to know what that length is. So if you decompose it this way, go ahead and erase that. Espen, which way do you think we should do it? Thumbs up if this is how you did it. Back row, did you guys do it this way? Because I don't have any response. Good. So, what are the dimensions of this top one? Kayla, what are the dimensions of this top rectangle?
43.
4.
4 times 3.
Remember, we're still using millimeters. So 4 millimeters times 3 millimeters. I want you to write that down. Brianna's going to be our carpet calculator, so she's going to put everything in the calculator for us. What do we get?
12.
So 4 times 3 is 12.
Millimeters.
Millimeters squared. All right, now I want you to think about this rectangle. I want you all to look at that. Put your pencil down and look. So I should see everybody's big old eyes. There we go. Is the length of this side 6? Nod your head or shake your head. No, it is not. We just cut that 6. This is 6, but this is not 6. What is the way that you could figure out what the length of that is? I want you all to really think about that. Tell your neighbor. So like you two are neighbors, and you two are neighbors, and these two are neighbors, and you two are neighbors, and you two, and then you 3.
Really?
How can we figure out what this length is? When you think you have it, put your hands on your knees. Raina, what did your group come up with? How could you figure out what that side length is? You all had your hands on your knees. I thought you had it.
I was like this.
You guys don't have it?
I do.
Okay. Jaden, what did you and your partner have?
If that 3 is the same size as that's
This
the
3?
no, the 3 up there.
This
And-
one?
Yeah, and if we cut the 6 in half, that makes that side the same length as the 3, so we can tell that the side is 3 millimeters.
This goes back to what makes a rectangle a rectangle. I want everybody to look up at me. A rectangle has 2 sets of opposite equal sides. So if we know that this is a rectangle and this side is 3, then the opposite side has to be 3 also. Well, it's not 6 and 3. That 3 has to come out of that 6. So this isn't 6. We're going to do 3 and 3. So now what are the dimensions of this square?
3 by
3 by 3.
millimeters.
3 millimeters by 3 millimeters. Calculator, what is 3 times 3?
9 millimeters. Guessing. It was
9. What do we do next? Jeanette?
Add 12 plus 12 millimeters squared plus.
What is 12 plus 9, everybody?
12 plus 9.
What is 29?
21. Don't
It's 21.
Remember what we talked about yesterday? Thinking before you speak.
Just like,
I want you all to make an observation really quick about how I wrote that down. I wrote the first rectangle's problem on top of this rectangle's problem. That way I could just add it right there. I want you all to try and do that. Go ahead and do number 3. You may work with your neighbor.
Oh, number 3.
Number 3.
Oh, no, I guess that.
Don't make that.
Okay.
You guys don't need calculators. These numbers are very small.
Okay.
You got about 2 minutes to finish this. Number 3. I don't see you all working with others. Yeah, no, I just want you guys to do number 3. Don't keep going. All right. Jade and Espen, can you come show us what you all did? I want you guys to talk to us while you're doing it. All right, James and Michael, are you guys ready to listen? Jaden, are you? Come on, tell us what you're doing.
We cut it in half like that, and then we said we ate times 3 times 3. 3 times 3 equals, and then we
Now, why do you have 3 times 3?
because of the we just cut because there's 16 because we just did 3 times 3.
Is that the dimensions of any rectangles up there? No, I don't think 3 times 3 works. You do 3 times something. Which rectangle do you want to do first?
6.
Okay, so fix that. I don't see respectful listeners right now.
We got that for the other one.
Okay, 3 times 6. What is 3 times 6, you all?
18.
18.
Oh. 18. And then we did 3 times 9.
Okay.
27. And then 27.
What is 3 times 9, everyone?
27. 30. What? Just trying to be cute. But apparently. In it.
Brianna, can you help them out?
So 8 plus 7 equals 45. 45. 7 is not equal 45. That's our answer.
Thumbs up or down that you get the same answer that they did. But it should be 45
Millimeters. Centimeters.
Not
Millimeters.
millimeters. That's good. There we go. Thumbs up if you got 45 millimeters squared. Or square millimeters.
There we go.
Good.
I fixed it.
If you're on the carpet, I want you to look at me. And I need you to assess again. Do you think you can do this now? Or do you need more help? If you think you can do this, I want you to go to your seat.
I need a calculator.
You may grab a calculator if you're going to your seat. If you are on reflex, log off and come to the carpet with your paper. You all leave the clipboards if you have them. Leave the clipboards if you have them. Group 3, if you do not need help, go get on reflex. If you do, come to the carpet. Group 1 should be on the carpet. Group 2, you are either coming to me or you are going to your seat to finish. Group 1 should have their paper on the carpet. You should be where you need to be in 5, 4, 3, 2, 1. Here on the carpet, I need your hands and eyes. Alex, I want you to go get your paper first, and then come sit right here on this side. All right, if you are with me, I want you to get your pencil down and your paper underneath your leg. Alright, I want you all to look at this. I have an irregular figure right here. What did I make this irregular figure out of? Sabrina? How did I make this irregular figure? The yellow one and the blue what? What are those? Daniel, what is this? I made them out of 2 rectangles. Say that.
2 rectangles.
Landon, I don't think you're with me. What did I make this out of?
2 rectangles.
Good. So, I want to make this easy for me, okay? Every time you think of an irregular figure, you want to think of it as rectangles. Now, the ones that look like L's are going to be made out of 2 rectangles. The bigger ones, like the one James broke down, are going to be made out of probably maybe more rectangles, all right? But you want to think about it like that. So I have one small rectangle, look. And then I have one bigger rectangle, right, Espen? Right, Jade? So I can't find the area of all this at once, right? So I want to find the area of one, and then I want to find the area of the other. Can you find the area of one rectangle?
No. Yes.
All right, that's a true question. Can you find the area of one rectangle?
Yes. Yeah.
Most of you can. If not, we have some help up here that you can use. So I want to do one rectangle and another, or sorry, one side plus times another to get my one rectangle. And then I want to find my smaller rectangle. Okay, so then I'm going to do my one side times the other, Landon. And then once I have the area of each of those, I'm going to add them back together, and I have the area of both. Thumbs up if you agree. Keith, I don't feel like you're with me. Okay, so I want you to look at the bottom one, number 9. I want you to think about, and this one?
Yeah. You missed a step.
Oh.
There you go, Miss
Okay.
L.
Think about it if you were making that on the geoboard. I have that one rectangle on the bottom. And then I have another one on top. I have that one on the bottom, and then I have that other one on top. I just want to do one at a time though. How many am I going to do at a time? One. How many things can you do at a time? Like in real life, how many things can you do at one time?
I can do
How many things can you do at one time? Well, one.
I can do two. Clean up and calm my dad.
Okay. But are you really paying attention to that conversation and cleaning up really good at the same time?
Yeah.
You're probably either cleaning up and kind of just listening, or you're having a conversation and things are just kind of getting a little straighter. One thing at a time. So on this bottom one, you want to do, you have 7 by 2. So to find the area of this rectangle, what are you going to do?
2 times.
Sabrina? Huh?